Hey, my dear friends, welcome to all of you once again, all the rockstars. I hope you are doing fine. Uh, so, on your platform, that is JE Physics Maniac, I am trying to incorporate the quality material substantially and obviously. This thing I am doing out of my passion. I hope you are able to learn something out of it. If you learn, then that will be my success. Anyway, so without wasting much time, let us go into that. So what it is saying that the variation of electric potential in two-dimensional xy plane has been given or has been shown in this diagram. There are two graphs, V versus X graph and V versus Y graph. And there is a charge minus q immediately released from point 2, 3. They are asking ki what is the acceleration of the charge. So it's a very simple kind of thing. It's an application of E equal to minus of dV dr. Now since there is x and y dependence, so separately I will write ex equal to minus del v del x and ey is equal to minus of del v del y. So ex becomes, if I substitute the value here, from 20 the value is coming to 0. So 0 minus 20 divided by x value is 4. So it is becoming 5 volt per meter. That is the x component of electric field. Fine. Similarly, for y component of electric field, I will write minus del v del y. So minus of, it is moving from 4 to 20. So that is 20 minus 4 divided by 4. It is coming to be minus 4 volt per meter. So immediately E vector will become Ex I cap plus Ey j cap, which comes to be 5 I cap minus 4 j cap. Now force equal to minus q into E vector, as the charge is given to be minus q here. Right? So force becomes this, then force equal to mass into acceleration, acceleration to force by mass. So minus of 5q by m I cap plus of 4q by m j cap. Q by m is given to be 2. So if I substitute, simply I will get acceleration equal to minus 10 I cap plus 8 j cap. Right? Easy question. Let's move on. So here in this case, they are saying there is a hollow conducting sphere of radius r that is fixed on insulating horizontal surface. That means this surface is insulating. They are mentioning that. That's fine. Now what they're saying, there is a small hole at the top of the sphere. There is a small hole. This hole they are talking about. And small charge drops of mercury fall from height h and enter the sphere through the hole. Each mercury drop has mass m and charge q. How many drops can enter the sphere? Right? Assume that nearby drop does not cause any change in the charge distribution on the spherical ball. Okay, fine. Let's assume. So let us think that there are n number of drops which are already fallen. There are n number of drops which is already fallen. So the charges will be on the outer surface, as it is a conducting spherical shell. So what is the number of charge here? That is equal to n into q. I am assuming n number of charges already fallen. And now I am thinking that n plus 1th charge is now falling down. So if n number of charge has already fallen and this charge has to be restricted, so it will be repelled away from here. So I am assuming this n plus 1th charge is just able to reach up to this, and the repulsion is so strong that it will not be able to enter. Right? Okay. So now I am conserving the energy for n plus 1th drop. So kinetic energy at point A, this is point A, and I'm taking this as point B. So kinetic energy at point A plus potential energy at point A is equal to kinetic energy at point B plus potential energy at point B. So when I'm talking about the potential energy, there are two potential energies. What are they? One is the electrostatic potential energy, and another one is the gravitational potential energy. All right. Both the forces are central forces, both the forces are conservative forces. Anyway, so what is the potential energy at point A? See, it is simply 1 by 4 pi epsilon naught. N into q is the charge on this shell into n plus 1th charge is falling. उसका charge कितना होगा भाई? Simply उसका charge q ही तो होगा ना? So 1 by 4 pi epsilon naught nq into. Now, for this charge at point A, this entire shell will behave like a point charge. So that means this interaction will be like this. The shell charge is concentrated at its center. How much charge it has? Nq. And this n plus 1th charge, that is q, is falling. So now this separation from ground to this is h, and this one they have given to be r. So this height becomes h minus r. So that's why I have written nq by h minus r into q, plus gravitational potential energy is mgh. Now next one. So when it is at the surface here, so 1 by 4 pi epsilon naught into nq by r into q, that is a potential energy between them, into mg into 2r, because charge is here means for the gravitational potential energy, I am taking this lower surface as the reference level. So if I take this surface as the reference level, this charge after falling here, it is at a height of 2r from the insulating horizontal surface. So that's why I have taken mg into 2r. So again, little bit of calculation. If you do the calculation, n value you will get mgr into h minus r 4 pi epsilon naught divided by q square, and that will be your desired answer. Right? Thank you very much. Thanks all of you.